us discuss an amazing topic that is called as nuclei. In this chapter, what is the meaning of size of the nuclei? And what factors the size of the nuclei depends upon? Let us discuss here in a brief way. So now, I am considering a nucleus. This is having a volume which is 4 by 3 pi r cube. It is having surface area 4 pi r square. 4 pi r square. So this is a small nuclei. What is the relation between the volume of the nuclei and its mass number? Let us imagine there are two nucleus, X and Y. Two different elements having their mass numbers 27 and 8. Let us imagine. They are having mass number 27 and 8. Now in this case, which is having larger volume? Definitely X is having larger volume compared to Y. The reason is, the larger is the mass number, the larger is the volume. With this it is clear that volume is directly proportional to mass number. You all know that any element, if you consider, it is having atomic number Z and mass number A. This is the way we represent the element. You all know about that, you are familiar with that. Now, if volume is directly proportional to mass number, then let us discuss what is going to happen. You all know that volume is 4 by 3 pi r cube is directly proportional to A. 4 by 3 pi is going to be constant here in this case. Then it is understood that r cube is directly proportional to A, r is directly proportional to A power 1 by 3. And in this case here, if proportionality is removed, you are going to get a constant. There is r is equal to r naught A power 1 by 3, where r naught is constant, which is taken as 1.2 Fermi, which is nothing but 1.2 into 10 power minus 15 meters. And it all getting one more relation, that r1 by r2 is nothing but a1 by a2 whole power of 1 by 3. So this is a relation between radius and mass number. Radius and mass number. Then let us discuss what is the relation between surface area and mass number. Okay, as we have said, we have taken one example, that is element X and Y having mass numbers 27 and 8 here. What are the ratios we shall discuss here. Now, let us find out the ratio of radius of these two elements if their mass numbers are given to us. It's very simple, that you'll write r1 by r2 is equal to a1 by a2 whole power of 1 by 3, where a1 is considered as 27 by 8 whole power of 1 by 3, which is nothing but 3 cube power of 1 by 3 whole divided by 2 cube power of 1 by 3. Then the ratio of radius is taken as 3 by 2, because 3 gets cancelled here in this case, a simple example. Now let us go for one more relation, that what is the relation between surface area of an element and its radius. It's very simple relation here. You all know that surface area is equal to 4 pi r square. With this it is understood that surface area is directly proportional to r square. And we also know that r is directly proportional to a power of 1 by 3. So from these two relations we'll get surface area is directly proportional to r square, which is directly proportional to a power of 2 by 3. Therefore s1 by s2 is equal to a1 by a2 whole power of 2 by 3. If this is the situation, if you take the same example, what is the ratio of their surface areas if the mass numbers are given about these two elements? Now let us see here. So S1 by S2 is taken as A1 by A2, which is 27 by 8 whole power of 2 by 3, which is nothing but 3 cube into 2 by 3 divided by 2 cube into 2 by 3. So 3 gets cancelled. What is left now? S1 by S2 is taken as 9 by 4. So if mass numbers are given, we can find out the surface areas also. Then what is the relation between velocity of the element and its mass number? So this is a new relation. Let us discuss in details. For example, there is an element like uranium which has been split into two elements like barium and krypton, having certain velocities v1 and v2. Let us imagine. So in this case, what is going to happen? Let us see. Here conservation of momentum takes place. Then if conservation of momentum takes place, momentum is going to be constant. We all know that kinetic energy and momentum relation is k is equal to p square by 2m. And kinetic energy is inversely proportional to mass. But in case of elements, we won't consider mass, we consider mass numbers. Therefore, kinetic energy is inversely proportional to mass number. But what is the relation between mass number and velocity? That is the question before us. As momentum is conserved here, momentum before and after is going to be same. So we can write v1 by v2 is equal to m2 by m1, which is masses here. But in the case of elements, we consider mass numbers a2 by a1. And what is the relation between radius and their mass numbers? radius and their velocities also we can find out now. So here we all know that radius is directly proportional to a power of 1 by 3. Then let us see what happens. What is the relation between radius and velocity after splitting? Radius of these two, let us imagine this is R1 and this is R2, velocities are V1 and V2. If velocities of these two splitted elements as given, then what is the ratio of their radius? We shall discuss now. It's very simple. So here, for example, R1 by R2 is equal to A1 by A2 whole power of 1 by 3. But A1 by A2, mass numbers and velocities are inversely related. Then we can write this as V2 by V1 whole power of 1 by 3. Okay, so R1 by R2 is equal to V2 by V1 whole power of 1 by 3. There is one question asked in 2019 that if the ratio of the velocities are given, like for example 27 by 8, if the velocity ratios are given, find out the ratios of their radii, then the very simple thing is you have to write R1 by R2. R1 by R2 is nothing but V2 by V1 whole power of 1 by 3. V2 by V1 is nothing but 8 by 27 whole power of 1 by 3. So 2 cube into 1 by 3, 3 cube into 1 by 3, you'll be getting 2 by 3 as your answer. Hope you have understood it very clearly. Thank you very much.